So today's lesson is notes on 2-4 biconditional statements. A biconditional statement combines a conditional statement with its converse. The key word is if and only if. You use if and only if for biconditional statements. The conditional symbol is P, the converse is Q, and the symbol for if and only if is IFF. If the sides of a triangle are congruent, so this is our hypothesis, then the angles are congruent. This is our conclusion. So this is our P and this is our Q. The converse of this statement is if the angles of the triangle are congruent, then the sides are congruent. We flip the Q and the P. So this would be Q and this is P. And for a biconditional, all you do is you get rid of the if, you get rid of the then, and instead of then, you write if and only if. So the sides of the triangle are congruent, if and only if the angles are congruent. So that's if and only if goes in the middle of that. So an example, write the conditional statement and converse from the biconditional. So this is our biconditional. An angle is obtuse, that's our P. If and only if it measures 90 degrees, that's our Q, between 90 and 180 degrees. That's our Q. So our conditional statement is if an angle is obtuse, then it measures between 90 and 180 degrees. Okay? The converse of that is if an angle measures between 90 and 180 degrees, then the angle is obtuse. So this is a true statement. An angle is obtuse if and only if it measures 90 degrees. And also the converse is true. If an angle measures between 90 and 180 degrees, then the angle is obtuse. Write the converse. If the converse is true, write a conditional statement. Be very careful. It says if the converse is true. You don't write a biconditional statement unless the converse is true. So in this case, if a polygon has 10 sides, then it's a decagon. Write the converse. If a polygon is a decagon, then it has 10 sides. That's your converse. Is that a true statement? If it is a decagon, then it has 10 sides. That is true. If that is true, we can write a biconditional. A biconditional, remember, is you take the original, you get rid of the if and the then, and you put if and only if in the middle. So the biconditional, so this was our converse, and our biconditional is a polygon has 10 sides if and only if it is a decagon. Okay? So you always check to see if the converse is true. If y equals 5, then y squared equals 25. So the converse is, if y squared equals 25, then y equals 5. That's not true, because what happens when y equals negative 5? Negative 5 squared equals 25. So this is our counter example. So you cannot write a biconditional if you have found a counter example for it. A good definition has to be reversible. Good definitions can be written as biconditionals. Reversible meaning the conditional and the converse are both true. So I have a definition here. Circumference is the distance around a circle. To write that as a biconditional, we have to say a measure is a circumference if and only if it is distance around the circle. You can't say if circumference then circle. It's not good English. So that's why we have to add words. That's why I wrote a measure is the circumference if and only if it is the distance around a circle. Sometimes you have to add words or to make it sound logical. So write the definition as a biconditional. An isosceles triangle has at least two congruent sides. So we want to make that a biconditional. An isosceles triangle has at least two congruent sides. So we can say a figure or a shape is an isosceles triangle if and only if it has at least two congruent sides. That's biconditional. Thanks for watching.